Hello and welcome to the solutions video for the Unit 4 Makeup exam. Alright, our first written response. So in this case we have to solve the equation absolute value of 4x plus 7 equals a negative 6x minus 5 algebraically and verify the work. Make a new whiteboard here. So now the question is absolute value of 4x plus 7 equals a negative 6x minus 5. So we have two cases, one where everything in the absolute value works out to be positive. So it'll be the case when 4x plus 7 is a negative 6x minus 5. We bring that over. That's a 10x equals negative 12, or x is a negative 6 over 5. We want to verify this. So our left-hand side, 4 times a negative 6 over 5 plus 7 is a negative 24 over 5 plus 7. Put that over a common denominator, that's a negative 24 plus 35 all over 5, or 11 over 5. Our right-hand side, negative 6 times a negative 6 over 5 minus 5, 36 over 5 minus 25 over 5 is 11 over 5. So our first solution, and potentially only solution, we don't know yet, is negative 6 over 5. That is verified. Now our second case to check is where everything in that bracket is negative. We multiply the whole thing through by negatives, and we get a 4x plus 7 equals 6x plus 5. That is, bring it over to the other side, we would have a 2x here and a 2 there. So x equals 1. We verify that algebraically. 4 times 1 plus 7 is 11. That's our left-hand side. And negative 6 minus 5 is negative 11, which is our right-hand side. Positive 11 and negative 11 are two different numbers. So our x equals 1 solution is an extraneous solution. So we have 4 marks here, 1 for each of the solutions, and 1 for the verification or proof that it's extraneous. Now we have two linked numeric response. They're worth half a mark each, so the whole thing is adding up to 1 mark. We have an absolute value function in piecewise form here. The invariant point, so this is the point which is the same for the two parts, or it's that point at the middle. Right, we want to find where x equals c. So for this one, we can graph it. So that was a 3 over 2x plus 1 and a 13 minus 3 over 2x. So here is our invariant point. Right, that's that 4, 7. This is the point where the two halves connect. It's also our vertex. So our x coordinate is 4, our y coordinate is 7. Now here, when we solve this algebraically, there will be two extraneous solutions. So neither of these will actually be a solution. We just have to solve for them. So in our first case, so for the first case, it's written as is, 3x plus 11 equals 2x minus 9. So 3x plus 11 is 2x minus 9, which gives us x equals negative 20. They told us that both are extraneous. We don't need to check it. We are coming up with the two extraneous solutions. The other one is where everything inside that absolute value is negative. And it gives us a 5x over here. And then that negative 11, we add 9 to get a negative 2. So x is a negative 2 over 5. These are the two. The greater solution, negative 2 over 5, is greater than negative 20. And negative 0.4 will not get you marks because there's nothing in this question that gives you permission to use decimals. Now, the value of the extraneous root of this equation is, again, we're asked specifically for the extraneous root because that's the one we cannot easily find by graphing. Right, if we were to just graph this, we would get the valid root, not the invalid root. So, what can help us with graphing, though, is when we do it algebraically, we'll find two solutions. If we were to graph this as, so we have f of x equals 2x minus 5. That's everything inside the absolute value. And then if we have g of x equals 5x minus 3. So these two are actually equal at this point. That's one root. If we want to know where the extraneous root is, we could graph a negative f of x and see where that intersects with g, because one of them will work. If we graph the absolute value, see the absolute value function intersects here. It does not intersect here. So this looks like a negative 2/3 and a negative 6 over 3/3. So if we put in x equals negative 2/3, our left-hand side, 2 times the negative 2 over 3, and then minus 5, is a negative 4 over 3 minus 5. We put it over the common denominator. Negative 4 minus 15 over 3. And that's a negative 19 over 3. While our right-hand side, 5 minus 3 times a negative 2/3 is a 5 plus 2. They should be the same value. Okay. So the 3's cancel. That's 7. So, yeah. This negative 2/3 is the one that doesn't match. So by graphing the function and the negative of the function, as well as graphing the right-hand side and the absolute value, we can see which of these pieces is not actually there. Yeah, so that is a negative 2/3 here. Now, is that the only extraneous root? Because the answer key is different. The answer key is saying 2, and 2 is an extraneous root. So, if we do this algebraically, 2x minus 5 is 5 minus 3x. 5x equals 10, x equals 2. But if we sub that in, 10 minus 5 is 5. Right? Or sorry, no, that's 2. 4 minus 5 is a negative 1 on the left-hand side. Take the absolute value of that, and we get 1 for the left. And our right-hand side is 5 minus 6, which is negative 1. So 2 is the extraneous root we find algebraically. So the graphical solution that we tried, trying to logic it out, doesn't actually work. Right, because I was looking at the wrong branch of the f. So, yes, the graph will not help us find extraneous solutions. Okay, so number 6. The importance of applying order of operations can now be demonstrated. So again, we treat absolute values as brackets. Within this one, we have a negative 6 plus 4, which is a negative 2. Absolute value of that is positive 2, so we're subtracting 6. We have the negative 5, so we're at negative 11. The negative 4 plus 17 is 13. Absolute value of 13 is 13. 13 minus 11 is 2. So the absolute value equation here, there's a single solution. So the valid solutions we can find graphically if we need to. So we have the absolute value of x plus 2. We have 3x, and there it is. So that happens at x equals 1. The extraneous solution, if we try graphing negative x minus 2, that's at negative 1/2. So we can make that adjustment if we do it algebraically. That would be the negative x minus 2 equals 3x. So negative 2 is 4x, x is a negative 1/2. So yes, that is our extraneous root, negative 1 over 2. Finally, we want to evaluate this one. So we have to be careful about where the absolute values are opening and closing, remembering that an absolute value cannot hold just an operation. So this is 2 minus 3, which is 1, the absolute, or negative 1, and the absolute value of that is 1. The right-hand side, 2 times 3 is 6, so this is 7. So we have 1 minus 7, which makes for a negative 6. So quickly going to score our written response. And we can submit. And this solves the Unit 4 makeup test.